Hello everyone, this is Shraddha Bhurre from my PhD Indore, and today we'll see comparison of iterative methods in numerical analysis and design. We have many iterative methods like bisection method, false position, Newton-Raphson, secant method, and successive approximation. All this method is used to calculate the root of our curve. The root is the point where our curve bisects the x-axis. So for finding this root, we have these methods. So we'll compare these methods first on the basis of iterative formula. So first, for bisection method, our formula is given by xi plus xi minus 1 upon 2. Here xi and xi minus 1 are in closed root. Our second method is false position, whose formula is given by xi minus 1 into fi plus xi into fi minus 1 upon fi minus 1. Here also xi and xi minus 1 in closed root. Now our third method is Newton-Raphson, and this formula is given by xi minus f of xi upon f dash of xi. Here we have to calculate the differentiation of function, and one more thing, we have to choose the proper initial point for this method. Now next is secant method, whose formula is given by xi minus 1 into fi plus xi into fi minus 1 upon fi minus 1. Here xi and xi minus 1 need not enclose the root. Now next method is successive approximation. His formula is given by xi equals to g of xi minus 1. Now second point is on the basis of order of convergence. So order of convergence is how fast our root will be reached in the method. So first is bisection method. In this method, we take x0 and x1, which encloses the root if f of x0 and f of x1 are of opposite sign. If they are of same sign, our root doesn't lie within the interval. The interval will be wrong at that time. So x0 and x1 is the such interval which is half in each iteration. Therefore, average rate of convergence will be 1/2 or 0.5. Each iteration takes us closer to root by one binary digit. For other methods, according convergent order theorem, each method is kth order convergent such that limit x tends to infinity ei plus 1 upon ei n less than equals to m. Here n is order of convergent. So if we suppose y as a root of our curve f of xi equals to 0, so our error term at I plus 1th iteration, will be given by xi plus 1 minus y, and our error term at ith iteration will be given by xi minus y. Now computing this value, putting this value in iterative formula and comparing with equation 1, that is with equation limit x tends to infinity ei plus 1 upon ei n less than equals to m, we'll get order of convergence for the following methods. Like for false position, order of convergence is 1. For secant method, order of convergence is 2. For Newton-Raphson, order of convergence equals to 1.62, and for successive approximation, order of convergence is 1. Now third point is on the basis of evaluation of function per iteration. For bisection, false position, secant and successive approximation evaluates only one function per iteration, that is f of x. But for Newton-Raphson method, we have to calculate two function per iteration. First is our f of x, that is our function, and second is differentiation. Now fourth point is on the basis of reliability of convergence. First, for bisection, guaranteed convergence. For false position is also guaranteed convergence to the root. Now third is Newton-Raphson, sensitive to starting value. Convergence fast if starting value is near the root. If we'll take the correct value, and that is the value which is near to our root, then our method will converge. Otherwise it gives no guarantee that our method will converge to our root. Secant, no guarantee of convergence if not near economical method. Now last is successive approximation, each to program, no guarantee of convergence. So on the basis of this 4 point, we have compared the iterative methods. Now thank you for watching video.